Hi, everyone. Thank you so much for joining us today for our webcast. We are going to give everyone a few more minutes to join. So hang tight, grab a cup of coffee really quick, and we'll be back in about 2 minutes. Thanks so much. Welcome, and thank you for joining us today for our webcast, Automating Apache Kafka Lessons Learned. We have a great webinar planned for you today. Before we get started, a few housekeeping items. This presentation will last about 45 minutes. Questions are welcome, and we encourage you to type any questions you have throughout the webinar into the Q&A section on the right-hand side of your screen. We will have a Q&A session at the end of the presentation when all of your questions will be answered. As a reminder, this webcast will be available on demand shortly after it concludes. Please see the attachment section for a PDF version of the slides, as well as some other helpful content. Now, without further ado, the reason you joined us today. Instaclustr recently extended their managed service for Apache Cassandra to include support for Apache Kafka. This presentation will walk through the key challenges and lessons learned in extending Instaclustr's provisioning and management system for Kafka. Specific details will include benchmarking, choosing appropriate cloud provider configurations, and security configurations. Our speaker today is Ben Slater, Chief Product Officer at Instaclustr. As Chief Product Officer, Ben is charged with steering Instaclustr's development roadmap and overseeing the product engineering, production support, open source, and consulting teams. Ben has over 20 years of experience in systems development, including previously as lead architect for the product that is now Oracle Policy Automation, and over 10 years as a solution architect and project manager for Accenture. He has extensive experience in managing development teams and implementing quality-controlled engineering practices. Ben, I'll hand it over to you.
Thanks, Gina, and thanks everybody for joining the webcast today, and for those of you in the future listening to this on replay. So I just want to start off with a bit of an introduction to Instaclustr. For those who may not be familiar with it, we provide open source as a service for applications with very large scale and reliability requirements. So we've got over 30 million node hours of experience managing Apache Cassandra is where our business sort of started and really the core of our business. We also work with Spark. We have Elasticsearch Early Access Program, and Kafka being the technology that we're talking about today. Our platform generally provides automated provisioning, monitoring, and management of those technologies. So basically you can build the application using those technologies, and we will take care of the rest, having a production-ready and reliable application. We're available on AWS, GCP, Azure, IBM Cloud, and actually doing some on-premises at the moment, so that is an option that we're actively working with as well. Our managed Apache Kafka was released in May this year, so actually the title's a little bit, our intro is a little bit out of date there, saying recently released. We're now several months in, and have quite a number of Kafka clusters, production clusters running under management. And as I mentioned, we are now moving on to Elasticsearch as the next technology we're adding to our platform, and have an early access program for Elasticsearch. So anyone who's interested in a better Elasticsearch managed service provider, we're certainly interested in talking to those customers. So with that introduction, basically what I'm going to do today is a bit of, as context, a bit more detail on our managed Kafka offering and the development process we went through to build that offering. And then really go through some specific topics, some sort of interesting things that we found along the way, and information that we thought would be more general interest about choices we made in the implementation and those kind of things. So specifically the hardware choice and some of the benchmarking that we did there, topic and user management, broker security configuration, monitoring, and backup and restores were all kind of interesting topics that along the way in building this offering, we had to do quite a bit of thinking about, had some interesting discussion, got some interesting information to share. So just to go through a few of the key features of our managed Kafka offering. So basically it's open source Apache Kafka and Zookeeper provisioned, as I said, in AWS, GCP or Azure. So you can come to our console, log in, fill in a pretty simple form, hit go, and within sort of 15 minutes, probably 10 minutes mainly, you'll have a production ready Kafka cluster up and running, ready to connect your application to. Our environment is all SOC 2 compliant, so we have a high level of security controls, externally audited, all of those good things. It comes with broker level and topic level monitoring, so a range of monitoring metrics available for both the broker and the topic. We take the approach of not giving you every single metric that Kafka provides, because there's a very large number of metrics, and it's actually quite hard as a user to work out which are the most important. We basically choose the most important set of metrics and make those available through our console, and then have additional metrics available ourselves as part of our job of managing the cluster. One of the other interesting things we do for monitoring is synthetic transaction monitoring, so actually running our own messages, a very small number through the Kafka cluster to monitor from that point of view, and I think we talk about that in a bit more detail later on. We have monitoring and provisioning APIs, so you can take the monitoring information and pump that into a single view of your application. Datadog, Prometheus are two popular choices. And you can use the provisioning API to build provisioning and destroying clusters in Instaclustr into your CI/CD pipelines. We have a feature called private network clusters, which is clusters with private IP, with only private IPs on the nodes, no public IPs, and a gateway automatically provisioned as part of the cluster to allow us to do our management requirements. We can run in our cloud provider account or your cloud provider account, so two different models, one where the price that you pay to us includes the cloud provider infrastructure, one where you pay the cloud provider bill directly and just pay us a management fee. Technically, they're pretty much the same underneath. We built, so because we don't expose Zookeeper as for managed service, we keep that internal, and we'll talk about why a bit later. We've built a custom CLI topic management tool that allows you to do all that topic management via the native Kafka APIs, but still have scripted topic management. We think that's a better practice than doing too much of that through the UI. We have user and credential management and support Kafka 1.1, and in the last month or two released 2.0 and 2.1 support as well. So that was a quick run through of the current features, and in development at the moment we have very close to release support for managed Kafka REST API, so just a tick box option when you provision a cluster to get REST API provisioned along with SSL certificates and all that kind of stuff, so fully secured. Managed service registry is also in the works. So again, it'd be an option just to get a service registry provisioned and then fully managed. And at some stage next year, we expect to release a managed Kafka Connect offering as well. All of those things are currently supported for use. You can use those with our managed brokers, but this will be full managed options where you just hit go and get a cluster up and running and full SLAs and those things. So that's kind of what we offer, just to go through a bit of the process of how we got there, again, for context. So really it was sort of back in 2016, we started having customers saying, you guys do a great job of managing Cassandra for us. We're also using Kafka. How about you have a Kafka offering as well? It would be very good. We then started in 2017 looking at internal deployments of Kafka and our internal usage of Kafka to really start to build up our own level of expertise and comfort with the technology before we had a customer offering for that. And that's a typical path that we'll take when we're offering new technologies. Then in November 2017, we commenced the development of our managed platform offering, early access program in December 2017. So we had 4 customers come through the early access program and start using the offering, or an early stage of the offering ahead of release to help us build more expertise and experience, and also to get requirements that work with those customers on requirements for the full offering there. And as I said, that's the program we're in with Elasticsearch at the moment. Public preview release was in May and general availability in June. Since then, the offering has been a really very strong success. We've got more than 20 clusters and more than 100 nodes of Kafka running. So really starting to build some deep experience in running Kafka across the board. So that background, we'll go into some of the more detailed sort of design considerations and kind of interesting points that we learned along the way. So one of the questions that we do sort of regularly is look at cloud provider offerings, and we do this for Cassandra as well as Kafka. Look at the new instance types that are available, the new disk offerings, all of those kind of things, and work out really for the typical use case of that technology, what looks to be the best price performance configuration that we can get from the cloud provider, with what the cloud provider infrastructure provides. And of course, we went through that with Kafka. One of the things that we looked at with Kafka was the type in AWS, the type of EBS volumes to use. So for Cassandra, we currently use what's called GP2 EBS volumes, which are SSD backed volumes, where the amount of IOPS that you get is proportional to the size of the disk. They have another SSD backed offering called provisions IOPS, where you can basically buy IOPS independent of the size, but it tends to be quite expensive. So we looked at the GP2 EBS versus what's called ST1 EBS, which is a relatively new EBS offering from AWS. It's backed by spinning disks, but designed for very high sequential access throughput, and quite a bit cheaper than GP2 EBS. In our benchmarking, we found that, at least for the use cases that we tested, that we got better performance through ST1 EBS, and it's 45% of the cost of GP2 for the same disk volume. So we went with we went with ST1 EBS for our AWS offerings, and they've achieved some pretty good cost savings for customers through offering that lower cost offering with demonstrated no drop of performance. And these graphs just show the variance. One interesting thing there too is you'll notice that the ST1 throughput was actually also more consistent than the GP2. So there's a bit more sort of jitter in the throughput on GP2 than there was on ST1. Another choice that we had to look at, maybe it's not really hardware choice, but another decision we made was around using SSL versus not using SSL, both for the broker-to-broker communications and for client-to-broker. We were considering whether to make that optional or whether to just require it as good security practice. So we did some benchmarking to have a look at that. We saw initially a 30% decrease in throughput for when we had broker and client SSL both enabled versus no SSL. However, then when we followed up some further benchmarking with JDK 9 versus JDK 8 that the initial benchmarking was done with, we saw a 50% increase in writes and an 80% increase in reads by using the new version of JDK. So basically all of that difference of the difference that came from turning on SSL, it was gone by using JDK 9. So we've basically gone with SSL turned on all the time for improved security and very minor performance degradation as a result. So that's automatically all provisioned, all of the certificates and so forth are all provisioned for each cluster when a new through the system. And these graphs just give you some of those benchmarking. I think that take a look on the slides available for download if you want to have a closer look at what we're showing there. Another thing we looked at was the impact of the number of topics on throughput. We sort of read various things about too many topics being very bad for Kafka and causing performance issues. And one of the things that you'll find, we've certainly found this with Cassandra, but generally with fast evolving technologies is often ideas will get around that applied to an earlier version of technology, and then they're addressed in a later release, and it takes a long time for those ideas to kind of die and stop being accepted wisdom. So we wanted to validate some of those things. So we did a bunch of testing with different types of topics to see whether that actually reduced throughput, and certainly in our testing we didn't see any significant drop in throughput as we increased up to sort of the 5,000 topic mark. However, what does happen is as you get more topics, you have more partitions naturally, and more partitions does lead to a slower recovery time from node failure. So each partition that has to fail over when a node fails has to go through a master election with Zookeeper, and that can be quite slow. So although it does not reduce as far as our testing showed, reduce your throughput, we still recommend keeping topics to a reasonable number, probably less than the kind of 1,000 number, because of the impact on recovery time from node failure. Another question that we had to answer was, could we and should we co-locate Zookeeper on the same nodes as the Kafka cluster? Again, it was kind of a recommendation floating around the internet for years about not running Zookeeper with Kafka. However, there have been some pretty significant architectural changes to Kafka recently to reduce the amount of information that is stored in Zookeeper, and certainly to reduce the frequency of writes and reads and writes from Zookeeper. In particular, consumer offsets used to be stored in Zookeeper, so keeping track of where each consumer was in the stream. That's been moved in more recent versions of Kafka from being kept in Zookeeper to being kept in Kafka itself, and dramatically reduced the read and write load of Kafka on Zookeeper as a result. So we did a bunch of benchmarking of that as well, and really couldn't find any measurable difference in performance of running Zookeeper on the same nodes as Kafka. And we've gone with that approach for our release offering at the moment of having Zookeeper on the same nodes of Kafka. We can see, however, there are probably still some potential benefits to separate Zookeeper nodes, particularly in failure scenarios of not having Zookeeper and Kafka fail at the same time when you have a node, and we're definitely keeping a close eye on that, and may well have that offering of separate Zookeeper nodes at some stage in the coming year. And again, just some graphs backing up that benchmarking result. So topic in user configuration management, I think I touched on this briefly in the introduction, but basically the Kafka utilities that are available now through the project require direct access to Zookeeper. But when we looked into the implications of that and making Zookeeper available, it doesn't really have a robust external security model. It's not designed to be at all externally exposed. And we really just didn't think we could provide sufficient security around that for it not to be a risk to expose that. And actually not just from a security point of view, but also the level of sort of Kafka configuration that you can drive through Zookeeper would make it very hard for us to provide a managed service when customers could potentially reconfigure quite significant things without us having any visibility. Then we have an incident, and we're operating blind, not knowing what has changed. So it also helps us keep things from that point of view, where we know how the environment is configured and can take responsibility for the availability of that environment. So what we did was develop a command line tool to use for the Kafka to use the Kafka API for topic configuration. So getting rid of any dependency on Zookeeper for doing that. That's available on our GitHub open source. I think that there's work in the project to be moving in the same direction as well. We may add console support through our console for topic management, just for a quick thing, but I think we would still strongly recommend that for versioning and configuration as code good practices. That actually a command line tool or similar is a much better practice than using a UI for adding and removing topics in any event. We did end up adding user management to the Instaclustr console. So if you want to add users to Kafka, that can be done via the console to create different logins for your Kafka cluster. One of the other challenges that we had to work through was the broker security configuration. So we had part of what drove us here is as part of our SOC controls, we had a need to have automatic rotation of the broker-to-broker credentials and any credentials that our administrators use for administration purposes. And that also kind of drove our requirements. So we've ended up using SCRAM, which is, as I said there, Salted Challenge Response Authentication Mechanism for the client to broker authentication, and we use what's called SASL plain text for the broker-to-broker authentication. So to give us that rotation. So the reason we use the plain text for broker-to-broker, we were planning to use the SCRAM authentication as sort of slightly more secure and more modern. But once we actually got to implementation, we found that although it's kind of noted in the documentation as dynamic configuration, it actually requires you to do a broker restart to rotate the credentials, and we didn't want an automatic process that was restarting brokers every time we needed to do a credential rotation. So what we're doing instead is using short-lived signed keys on the brokers, which are a truly dynamic configuration, so we can rotate those keys on a regular basis without restarting the process. So that's an automatic thing that just happens on the clusters as part of our management of them. So the broker security configuration, we've got a few things there to manage the access to the clusters. So the options that we provide are basically we have public IPs, and you can use public IPs to connect to the broker nodes, and then use the whitelisting in the firewall security group or equivalent of the other providers to control where you can access from. Obviously, recommend using authentication as well. We support VPC peering and kind of the equivalents in the other cloud providers to allow you to access via private IPs to keep the traffic entirely private. And as I mentioned in introduction, we have the private network clusters in AWS where we don't have public IPs on the node at all and automatically provision a gateway box as part of the cluster. As I said, we don't expose Zookeeper at all due to the weak security model. So looking at it through our SOC 2 assessment lens, we just didn't think that was a valid thing to be doing. So monitoring is always another big topic of work, I guess, in building our managed service, both for Cassandra and for Kafka. So the way we do that, we have our own monitoring solution that's kind of designed for our problem of monitoring thousands of pretty similar servers with one central team. We have a custom collection agent on each node that currently uses RabbitMQ to send metrics back to Ryman stream processing engine, and we have a pretty interesting Ryman implementation that's horizontally scaled and highly available. There's a blog post we did about that implementation. We then write all the metrics into Cassandra and use Spark to do roll-ups, and that's what's then provided through our console, through our APIs, and internally through Grafana to view all of the metrics there. So for Kafka, because it's Java similar to Cassandra, exports things via JMX, it's basically a matter of hooking that agent up to Kafka and then working out which were the most important metrics for us to work with, both provide to customers and for our support team to be looking at. As I said, so through that architecture, we collect both broker level and per topic metrics and make those available through the console and API. And then we have a range of alerting rules that are used to alert our management team should there be any issues with the cluster to jump in and rectify them to meet our SLAs. So we have the basic kind of metrics of server state, disk usage, and free space, and the server's actually still there and checking in. We then look at some Kafka-specific metrics, so offline partitions, having more than one active controller, partitions under replicated are all indicators of an unhealthy Kafka cluster, potentially before it actually stops failing, before it starts failing. You may see some of those things. The active controller one, as I mentioned there, it does seem to be a bit oversensitive, and we're tuning that metric at the moment. And then the last thing I mentioned in the intro is we do synthetic transactions. So our agent actually creates its own topic and publishes and consumes sort of 10 messages every 20 seconds to and from that topic, measures the success of that operation and measures the latency of that operation. So we can then have monitoring rules based on, are we able to successfully publish and consume messages from effectively our own controlled consumer and producer running on the cluster, and is that happening in a timely fashion, both which are really good indicators of any lack of health in the cluster. So backup and restore. Backup and restore was certainly a very interesting one that we worked through, and I think we're still working through to a degree. So the kind of internet wisdom is that really Kafka backups are not a thing. You don't back up Kafka. The data is already replicated, and you could use Mirror Maker, say, to replicate to another cluster if you really want backups. There's some validity to that argument, but I think you can make a very similar argument to Cassandra, and certainly our experience running Cassandra has shown us that there are still very rare but occasional cases where backups are very valuable to have. So we weren't really comfortable with a zero backup situation. And examples are, corruption due to an application bug, where you start writing invalid messages or something, user error, those kind of things that can actually be spread by replication. Simultaneous hardware failure, very, very unlikely, but not entirely impossible, and something possibly to consider for some scenarios. So what we do at the moment is we do automated backup and do restore of the topic and security configuration. So we can restore a cluster with the same configuration as an existing running cluster. We don't do data backup at the moment, which is as a sort of common practice in Kafka, and so that's kind of left if you need to back up your data, then you can use Kafka Connect to write whatever messages you need to back up for a long time to offline backup or a similar solution. Right, so that's covered the main, or at least a selection of interesting things. Hopefully that's provided some interesting information about behind the scenes of how we went about building that managed service. If it sparks some interest, then give it a try. Go to Instaclustr.com. You can log in and have a free trial, spin up a cluster, and get a feel for how it works. I think I've got a few questions now.
Awesome. Thanks, Ben, for a great presentation. We do have a couple questions that have come into the presentation. I encourage you to continue to type those in if you have any additional ones with the end of the presentation. So Ben, one that came in kind of early on is, what service registry? Is it schema registry?
Yeah, sorry, I misspoke there. That is schema registry, not service registry.
Okay. And then another one that came in is, how are you different than Confluent's offerings for Apache Kafka?
Yeah, there's a couple of key differentiators. I mean, at the highest level, I would say our biggest differentiator is that we are 100% focused as a business on operating these technologies and providing extremely reliable environment to run them. So that's what our business does, and it's a bit intangible, but in terms of we started with Apache Cassandra, and that is a database that you only use if you have a very serious, significant requirement, generally an application that your business depends upon. And so we've built our business for that level of requirement, and that's what we bring to Kafka. And a company like Confluent is a little bit has multiple irons in the fire with different models there. Once you get down to the tin tacks, things like having a run in your own account offering, so being able to actually run in your own cloud provider account, I find is very attractive to particularly more larger enterprises and more serious users. Look at the SLAs that we provide on things like response and those kind of things. Ours are generally ahead of that. So at the technical level, there may not be a lot of difference, but we genuinely believe that at the experience level, there's quite a strong differentiation there.
Awesome. Another question that came in is, what is the biggest lesson learned from Kafka?
What is the biggest lesson learned from Kafka? I don't know. I mean, I think we certainly learned that a lot of what we already knew from Cassandra was highly applicable to Kafka. There's some Kafka-specific things, but I think they're the things that I went through in the presentation. Really, it's hard to pick out one as the biggest lesson learned.
I think a couple of questions came in after you were talking about the differences between us and Confluent, but how does it work to run in your own account with a managed service through Instaclustr?
Yeah, so basically the way it works is, say in AWS, you set up, typically and nearly always people will set up another child account under their existing AWS account for billing purposes. That child account, we set up a trust relationship so that our provisioning system has access to create and destroy objects in that account. And once that's done, it operates exactly the same as running in our account. So the full automated provisioning, all of those kind of things, we have our team has the same level of access to instances running in that account. But it's running in your account. You get the infrastructure bill. It's totally transparent what that is. You get the benefits of any volume discounts from AWS and those kind of things, and you have a little bit more visibility and comfort that it's something you can see exactly what's going on with. And there are some technical scenarios such as using AWS Direct Connect or those kind of things, which are a lot easier to facilitate when we're running in your own account than if you're trying to run in our account.
Awesome. Another question that came in is, what is your SLA time?
Yeah, so our response time SLA for tickets is 20 minutes. We typically respond a lot faster than that, particularly if it's any kind of serious issue. We also provide availability and latency SLAs. So and that actually our response is driven mainly is also driven by maintaining those SLAs.
Great. Another question that came in about running in your account versus our account. Do we have access to our data and account if we run in your account?
Yes. So in either scenario, running in our account or running your account, our administrators are able to log into the system that we're managing in order to manage it, and can potentially access the data in that scenario. We have extensive controls through our SOC 2 process to manage that, to audit that. We go through that with quite a number of large enterprise clients to ensure that people are happy with that, and generally find these days that we can get through those kind of questions very well.
Great. I think that's all the questions we have. I'll give you just a few more seconds in case there's any that you are typing in now. We will be releasing our 2019 webinar schedule shortly, so please come back to our BrightTalk profile for information. We will have our first one in the first week of January, so please stay tuned for that. Thank you again to Ben Slater for a very informational presentation. There's a lot of great content there. I encourage you all to look at our attachment section in the webinar platform for the slides, as well as other helpful content around Apache Kafka and some white papers that could be of interest to you. It looks like there are no outstanding questions, so this concludes our webinar today. Thank you so much, everyone, for joining us. Thanks again to Ben, and we look forward to seeing you on our next webinar. Thanks so much, and have a great day.